Good morning, all of you. Welcome to Sri Jay in the Tank Zone. So far, we have completed general properties in D and F block elements. Now, in this session, we are going to discuss preparation properties of potassium permanganate. So, please listen carefully. Potassium dichromate and potassium permanganate. We are going to discuss in this session. It's very, very important for entrance exams. So, now I'm starting. Next, coming to next topic in this chapter, oxides and oxoanions of metals. Oxides and oxoanions of metals. So as the oxidation number of metal increases, ionic character decreases and acidic nature increases. So very, very important this statement. Please listen carefully. As the oxidation number increases, of metal increases, ionic character decreases and acidic nature increases. So for example, if you see that as chromium oxide, oxygen state of chromium is +2. So it is basic in nature and it is ionic. Whereas chromium dioxide, that is chromium oxygen state is 4 +4. So it is amphoteric in nature. Similarly, chromium trioxide, that is chromium oxygen state of chromium is +6. So it is acidic in nature and this is covalent in nature, completely covalent in nature. And this can be ionic as well as covalent. So, but the nature of this oxide is amphoteric. What are amphoteric oxides? Which can combine with acids and bases to give hydrogen gas. So they can combine with acid as well as base and form hydrogen gas. That's why they are called as amphoteric oxides. Similarly, manganese dioxide, manganese oxide, manganese +2 state, and amphoteric Mn3O4. Mn3O4, it is here. It is actually so. If you take Mn3O4 oxygen state, if you calculate, easily you can get it. So 3x minus 8 is equal to 0. Implies 3x is equal to 8. So x is equal to 8 by 3. So it is greater than 2 but less than 3. So here, that's why the oxygen state of manganese is 8 by 3. And here it is plus 4. And here it is +7. So as the oxygen state of manganese increases, it changes to amphoteric nature to acidic nature. So this is covalent in nature, whereas this is ionic in nature. Basic oxides are ionic in nature and acidic oxides are covalent in nature. Amphoteric have partial character of ionic, partial character of covalent. So Mn2O7 gives MnO4, that is HMnO4, that is KMnO4, you can take it as KMnO4 or HMnO4, and Cr3 gives H2Cr2O4 and H2Cr2O7 when on reaction with acids. So this is the nature of oxides and oxoanions of metals. It is very, very important. So these two are acidic in nature and this is acidic in nature, and that's why they are giving acids, that is potassium dichromate or dihydrogen dichromate. This is dichromate ion. Dichromate, Cr2O7 is dichromate. Next. Next, potassium dichromate, preparation and properties. Now in this chapter, we have only two topics left, that is potassium dichromate, preparation and properties, as well as potassium permanganate, preparation and properties. After that, this D block will be finished. Then we will go for F block elements. Now coming to potassium dichromate, that is K2Cr2O7. So potassium dichromate is an important compound. This reaction they can ask in the examination. So dichromates are generally prepared from chromate, which in turn is obtained by the fusion of chromite ore. Chromite ore is FeCl2O4 with sodium or potassium carbonate in free axis of air. So that is chromite ore along with sodium carbonate and oxygen in the free axis of air. Air means oxygen. It forms sodium chromate, ferric oxide, and carbon dioxide. This is called sodium chromate. Sodium chromate. From this sodium chromate continuation, The yellow solution of sodium chromate is filtered and acidified with sulfuric acid. These sodium chromate crystals are filtered and acidified with sulfuric acid to give a solution from which orange sodium dichromate can be crystallized. This orange sodium dichromate, on reaction with sulfuric acid, it forms sodium dichromate along with sodium ions and water. Sodium dichromate is more soluble than potassium dichromate. So sodium dichromate on reaction with potassium chloride, it forms potassium dichromate. So this is the formation of potassium dichromate. It is orange color in nature. So orange crystals of potassium dichromate crystallize out. So total 3 steps. Very, very important. Preparation of potassium dichromate. So what is the oxidation state of chromium in potassium dichromate? So it is +6. That's why the equivalent weight is equal to equivalent weight of potassium dichromate is equal to molecular weight by 6, because it is losing 6 electrons. So that's why molecular weight by 6, number of electrons gained or lost. To find equivalent weight of an oxidizing agent, we can say molecular weight by number of electrons gained or lost. So it is, as it is oxygen state is +6, means it is losing 6 electrons. So equivalent weight is equal to molecular weight by 6, that is 294 by 6. 294 is the molecular weight of potassium dichromate by 6. This also they can ask in the examination. So what is the equivalent weight of potassium dichromate in acidic solution? It is molecular weight by 6. I repeat the statement. Equivalent weight of potassium dichromate in acidic medium. Equivalent weight of potassium dichromate in acidic medium. It is equal to the molecular weight by 6. This is very, very important. So this is the preparation of potassium dichromate. What is the color of potassium dichromate? Orange color crystals. Orange crystals of potassium dichromate is formed. Next continuation. Properties. Now, since the preparation of potassium dichromate is finished, now we are going to discuss the properties of potassium dichromate. Sodium and potassium dichromate are strong oxidizing agents. Very, very important. They are strong oxidizing agents. Means what? What is an oxidizing agent? An oxidizing agent will bring oxidation to others and itself undergoing reduction. An oxidizing agent brings oxidation to others and itself undergoes reduction. This is called oxidizing agent. Potassium dichromate is used as oxidizing agent and primary standard in volumetric analysis. This volumetric analysis, this you might have already done in 11th class. So for the estimation of solution, for the estimation of concentration of a solution, we will use volumetric analysis. That is also called as, we will call it as titrations. Volumetric titrations. Volumetric titrations will use potassium dichromate. We'll use potassium dichromate for as titrating agent, titrant. So potassium dichromate in acidic medium, as I told you, gains 6 electrons and forms 2 of Cr plus 3, that is chromium from +6 state to it changes to +3 state. Since 2 chromiums are there, so it is gaining 6 electrons. It is gaining 6 electrons. So it forms along with water, and the electrode potential is 1.33 volts, and equivalent mass, it is equal to molecular mass by 6, that is equal to 294 by 6, it is equal to 49. So the equivalent weight or the equivalent mass of potassium dichromate acidic solution. Acidic means H plus ions. H plus ion shows it is acidic in nature. So the equivalent mass of potassium dichromate in acidic medium is equal to molecular mass by 6. That is 294 by 6, which is equal to 49. This also they'll ask in the entrance examination as objective question. So this total point is very, very important. Next continuation. Let us see the properties continuation. Thus, acidified potassium dichromate, as it is a good oxidizing agent, it oxidizes iodides to iodine. What is the oxidation number of iodine here? It is -1. So the oxidation number of iodine is -1 and changing to 0. So -1 to 0 means increase in oxidation number. Increase in oxidation number. So it is called oxidation. As it is increasing oxidation number, it is called oxidation. Similarly, sulfides to sulfur. Sulfides, it is -2, and sulfur, it is 0. So acidified potassium dichromate oxidizes iodides to iodine, sulfides to sulfur, tin to tin 4 oxide, Sn plus 2 to Sn plus 4. So increase in oxidation number. Increase in oxidation number, again it's oxidation. And everywhere it is 6 electrons is common. and ferrous to ferric ions. So Fe plus 2 to Fe plus 3, increase in oxidation state. In above reactions, potassium dichromate is reduced to Cr plus the salt. In all these reactions, potassium dichromate is reduced to 2 chromium plus 3. If you want to complete reaction, you can write like this here. For example, I show it to you. Please note it down. Potassium, these are all half reactions. Potassium dichromate plus sulfuric acid. It forms potassium dichromate plus sulfuric acid. It forms 2Cr 2SO4 taken as chromium sulfate, because chromium in plus state, so sulfate will go like this, and iron oxide. So here Fe plus 2 you have missed out. So if you take Fe, so FeO, then it changes to Fe2O3, Fe2O3. That is iron in plus 2 state here, and is going to plus 3 state. So this is Fe2O3, so 2 FeO, right? So balance you can do plus 7H2O, 7H2O. So remaining you can do the balancing. This is the complete equation. So potassium dichromate on reaction with sulfuric acid along with iron FeO, it forms chromium sulfate plus ferric oxide plus H2O along with potassium sulfate also. Potassium sulfate also, because all the three sulfuric acid will not come here. So sulfuric acid, potassium sulfate also. This is a complete equation. So complete equations you can ask. They will ask either ionized equations. These are called ionized equations, and these are called complete equations. In all these reactions, we can say potassium dichromate is a good oxidizing agent. So it oxidizes iodides to iodine, sulfides to sulfur, tin 2 dioxide, that is tin 2 plus 2 state 2 plus 4 state, that is stannous to stannic. We can say it is called stannous to stannic. Stannic means higher oxygen state. Stannous means lower oxygen state. So it is plus 2 and this is plus 4. Ferrous to ferric. Ferrous to ferric. So in the above reactions, potassium dichromate is reduced to chromium salt, that is chromium sulfate. Next continuation. Some more reactions of potassium dichromate. All these reactions they'll ask in the objective exam. Even they'll ask balanced chemical equation also. So please write all those 4 equations as balanced chemical equations. Next, the chromate ion, that is CrO4 2 minus. CrO4 2 minus is tetrahedral, whereas the dichromate ion consisting of 2 tetrahedrals sharing one corner with CrO bond angle of 126 degrees. So the tetrahedral shape, it changes, it takes place the shape of tetrahedral. Chromate ion, this is CrO4 2 minus, CrO4 2 minus 1 minus 1 and minus 1. So it is CrO4 2 minus, and this is changing to dichromate ion, that is Cr2O7 2 minus, Cr2O7, and each chromium, these 2 chromiums are joined by 1 oxygen atom. So, and here 1 O minus and here also 1 O minus. Then the bond angle, bond length is 1.63 angstroms, and here the bond length is 1.79 angstroms, and the bond angle between 2 chromiums along with oxygen is 126 degrees. CrO-Cr bond angle is 126 degrees. So this is the shape of chromate ion. So in chromate ion, how many sigma bonds, how many pi bonds also they can ask in the examination. So if you take this into consideration, this is 2, 1. So here 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma, 7 sigma, 8 sigma bonds. So it's consisting of 8 sigma bonds. And how many pi bonds? How many double bonds? 1, 2, 3, 4. 4 double bonds. So it is consisting of 4 pi bonds. 4 pi bonds, 8 sigma bonds. So sigma bonds means for double bond you have 1 sigma, 1 pi. So 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma, 7 sigma, 8 sigma. So total there are 8 sigma bonds and 4 pi bonds. This is also very useful information. So potassium dichromate ion. So in potassium dichromate, number of sigma bonds and pi bonds will become 8 sigma bonds and 4 pi bonds. And this potassium O minus is there, no? For this, it will go for potassium, and this also will go for potassium where minus is there. So then if that is also taking place, that is potassium dichromate, if you take into consideration, then potassium will come here. This minus K plus will come here. K plus will come here. So due to which what happens, it will add 2 more sigma bonds. Suppose if they ask number of sigma bonds and pi bonds in dichromate ion, it is 8 sigma bonds and 4 pi bonds. Whereas if they ask number of sigma bonds and pi bonds in potassium dichromate, if they ask, then it is equal to 10 sigma bonds, because these 2 sigma bonds will add up, and 4 pi bonds. So please note it down in your class work. So potassium dichromate consisting of 10 sigma bonds, 4 pi bonds. Whereas chromate ion consisting of, chromate ion means Cr2O7 2 minus. So this is dichromate ion. So dichromate consisting of 8 sigma bonds, 4 pi bonds. Whereas potassium dichromate consisting of 10 sigma bonds, 4 pi bonds. Similarly for this also, it is 1, 2, 3, 4. So 4 sigma bonds and 2 pi bonds. 4 sigma bonds and 2 pi bonds for chromate ion. So chromate ion consisting of 4 sigma bonds and 2 pi bonds. Suppose if they ask potassium chromate, that is K2CrO4, K2CrO4, potassium chromate. So it becomes, then it forms how much? It is equal to 6 sigma bonds and 4 pi bonds. How many sigma bonds? 6 sigma bonds and 2 pi bonds, 2 pi bonds as it is. So if they ask for potassium, you'll get like this. So chromium, dichromate ion, 8 sigma bonds, 4 pi bonds. Potassium dichromate, 10 sigma bonds, 4 pi bonds. Chromate ion, 4 sigma bonds, 2 pi bonds. And potassium chromate, this is K2CrO4, is called potassium dipotassium chromate. So it is equal to 6 sigma bonds and 2 pi bonds. So even they can ask the structure, they can ask number of sigma bonds and pi bonds. So if you want to know for the sigma bonds and pi bonds, definitely you have to remember the structure. So this is the structure of potassium dichromate and chromate ion. Both are tetrahedral, but in potassium dichromate, we have 2 tetrahedrals sharing one corner with CrO bond angle of 126 degrees. So it consisting of 2 tetrahedral structures. Very, very important. Continuation. So any point they can ask in the entrance exam. So you should be thorough with all the points. The chromates and dichromates are interconvertible in aqueous solution depending upon pH of the solution. So the chromates and dichromates, so depending upon the pH of the solution, they can be interconvertible. The oxygen state of chromium in both is +6 only. Very, very important, because in CrO4 2 minus also, it is equal to +6. And Cr2O7 2 minus also, it is equal to +6. So in both the states, the oxygen state of chromium is +6 only. That's why they are interconvertible in aqueous solutions, depending upon the pH of the solution, because the oxygen state of both chromiums in both the solutions is same, that is +6 only. So 2CrO4 minus in H plus ions, it forms Cr2O7 2 minus. Similarly, Cr2O7 2 minus in basic medium, it forms CrO4 2 minus. So these are interconvertible solutions depending on the pH of the solution. So if the acidic solution, chromate ion changes to dichromate ion, and basic solution, dichromate ion solution changes to chromate ion. So these two are interconvertible in aqueous solutions depending upon the pH of the solution. Continuation. Now, potassium permanganate is potassium salt of permanganic acid. It is preparation. So permanganic acid. Now we are going to deal with potassium permanganate. Next important compound, potassium permanganate. After this only we'll discuss questions based on this topic. So potassium permanganate is potassium salt of permanganic acid. Preparation now you can see here. So manganese dioxide, this is called pyrolusite ore. What is the name of this ore? It is called as pyrolusite. Pyrolusite. Pyrolusite ore is nothing but what? It is nothing but manganese dioxide. So manganese dioxide, when fused with potassium hydroxide in basic solution or oxidized with air or potassium nitrate, it forms potassium nitrate. It forms manganese dioxide, manganese tetroxide, that is MnO4 2 minus. And the oxygen state of manganese in this is X minus 8 is equal to -2. So here it is +4 and here it is engaged to +6, because manganate ion. So X minus 4, X minus 8 is equal to -2. So 8 going there, so it becomes +6. On electrolytic oxidation of alkaline solution, it forms permanganate ion. Permanganate ion means it is changing to +7 state. So manganese dioxide, when fused with alkali, that is potassium hydroxide. Potassium hydroxide is alkali soluble base. It changes to manganate ion. Manganate ion, when on electrolytic reduction, oxidation in alkaline solution, on electrolysis, it forms manganate ion. So manganese dioxide pyrolusate O2, permanganate ion. Finally, it forms MnO4 minus. The oxygen state of manganese in this is +7 state, +7. So electrolytic oxidation of manganate, this is called manganate ion. Manganese dioxide, manganate ion, and permanganate ion. Continuation. So it is prepared by the fusion of manganese dioxide with alkali metal. First preparation of potassium permanganate. It is prepared by the fusion of manganese dioxide, which is also called as pyrolusite ore, with an alkali metal hydroxide, that is potassium hydroxide or sodium hydroxide, and an oxidizing agent like potassium nitrate. This produces the dark green potassium manganate. Here it is called potassium manganate. Oxygen state of manganese is +6, and here it is +4. That's why it is oxidizing, which disproportionate means simultaneous oxidation as well as reduction for manganese only in a neutral or acidic solution to give permanganate. Let us see now disproportionation. So manganate ion, so it is oxygen state of manganese is manganate ion. This is MnO4 minus on reaction with KOH. So MnO4 2 minus actually it should be on reaction with potassium hydroxide. It forms K2MnO4, K2MnO4. So this K2MnO4 along with water. So this MnO4 2 minus ions combines with acidic medium to form permanganate ion. This is called permanganate ion and along with manganese dioxide. So here you can see here what is the oxygen state of manganese. It is +6. +6 changing to +7 as well as +4 again, +4. Here it is +4. So it is +4. So +6 changes to +7, +7, +4. So increase in oxidation. Increase in oxidation number, it is called oxidation. And manganese +6 changing to manganese +4. So decrease in oxidation number, it is called reduction. That's why we can say this is called disproportionation reaction. So manganate ion in acidic medium changes to permanganate ion along with manganese dioxide, which is called as a disproportionation reaction in a neutral or acidic solution. So even this we can take it in water or even acidic solution, that is H plus ions. So in the laboratory, manganese 2 ion salt is oxidized by peroxo disulfate to permanganate. So this is called sodium thiosulfate. Sodium thiosulfate formula is Na2S2O8. Na2S2O8, sodium thiosulfate. So instead of taking Na2, they have taken S2O8 2 minus. It is nothing but Na plus and 2 minus. So manganese plus 2, this is ionic equation. In neutral medium forms permanganate ion along with sulfate along with acid. So this is called laboratory preparation of potassium permanganate, and this becomes here sodium sulfate, Na2SO4, and this becomes potassium permanganate. This is even if you take potassium or sodium permanganate, so you'll get both. So in the laboratory of manganese 2 ion salt is oxidized by peroxo disulfate to permanganate, peroxo disulfate to permanganate. Permanganate means MnO4 minus. The oxygen state of manganese is +7. And here it is +2. +2 to +7, difference is 5. So that's why it is called oxidation reaction. Very, very important. In this, what type of questions you will get also we'll discuss later on after finishing this topic. And even potassium permanganate is also a strongest oxidizing agent. It is also called the strongest oxidizing agent, means it brings about oxidation to others and undergo itself reduction. It can be reduced to manganate, manganese dioxide, and manganese 2 salt, depending upon hydrogen ion concentration. So in acidic medium, permanganate ion changes to Mn plus 2. Very, very important. So from this, they'll ask, what is the equivalent weight of potassium permanganate in acidic medium? Equivalent weight of potassium permanganate in acidic medium in H plus ions. So in acidic medium, it is equal to molecular weight by, very, very important, change in oxygen state, it is +7 changes to +2. So it is 5. Similarly, potassium permanganate in alkaline medium, +7 changes to +4, +4. So +7 changes to +4. So in alkaline medium, potassium permanganate changes to manganese dioxide. So in alkaline medium, so equivalent weight of potassium permanganate, similarly right here, equivalent weight of this they'll ask in examination. So equivalent weight of potassium permanganate in alkaline medium, that is basic medium, you can say that is OH minus, it is equal to, that is what in alkaline MnO4, which actually this should be OH minus. This should not be OH plus, it should be OH minus. So it is equal to molecular weight by difference 7 plus 7 to changes to 3. So it should be 3, molecular weight by 3. And this finally it is equal to molecular weight by 1 because plus 7 changes to plus 6. So molecular weight. So potassium permanganate, equivalent weight of potassium permanganate in neutral medium. Equivalent weight of potassium, here I'm writing as there is no space. So equivalent weight of potassium permanganate in neutral medium. It is equal to, neutral medium means it is equal to molecular weight by 1 because only change in oxygen state is 1, plus 7 changes to plus 6. So definitely they will ask, and electrode potential is plus 1.52. Electrode potential is plus 1.69 volts. This anyway, this value is not important to remember. Only this is important. So please note down in your classwork all these 3 points. That is equivalent weight of potassium permanganate in acidic medium, equivalent weight of potassium permanganate in alkaline medium. Similarly, equivalent weight of potassium permanganate in neutral medium. All these values they will ask in the examination, entrance exams. Please listen carefully and write it in your classwork. So on the whole, potassium permanganate is the strongest oxidizing agent. It brings about oxidation to others because it is bringing oxidation to acid and itself undergoes reduction. That's what I told you. Plus 7 changes to plus 2 means it is undergoing reduction. Next, in acidic solutions, potassium permanganate in acidic solutions, it oxidizes iodine to iodide to iodine. Here also, again you can see here, please clearly. So it is plus 7 state changes to plus 2 state. So it is nothing but what? Equivalent weight is equal to molecular weight by 5. So iodides to iodide. Sorry, iodine. So oxygen state is minus 1 to 0. So oxidation, because minus 1 changes to 0 means increase in oxidation number. And this is decrease in oxidation number. Plus 7 changes to plus 2 means decrease in oxidation number. So on the whole, it is a redox reaction. So iodine minus changes to iodine 0. So increase in oxidation number. So it is called, it brings about oxidation to iodide ions to iodine. Similarly, it oxidizes nitrite to nitrate, nitrite NO2 minus to nitrate NO3 minus. You see the oxygen state of nitrogen here. What is the oxygen state of nitrogen here? NO2 minus. So it should be x minus 4 is equal to minus 1, means x is equal to plus 3. And here it is plus 5. So the oxygen state of nitrogen is increasing from left to right. The oxidation number of nitrogen is increasing from plus 3 to plus 5. So it is nothing but oxidation. So manganate ion changes nitrite ion to nitrate ion. Similarly, sulfides to sulfates. Sulfides to sulfates. So oxygen state of sulfur is x minus 6 is equal to minus 2. It is plus 4. And here it is plus 6. So increase in oxidation number in sulfur. So it is nothing but oxidation. So sulfide is oxidized to sulfate, nitrites to nitrate, and iodides to iodine. Just like potassium dichromate, it also oxidizes iodide to iodine, nitrites to nitrate, sulfides to sulfate, black lead sulfide to white lead sulfate. PbS changes to PbSO4. This is also done by potassium permanganate as well as potassium dichromate. So this is black lead sulfate. We'll call it as black color, black lead sulfate to white lead sulfate, white color lead sulfate. Please note down this also. So potassium dichromate and potassium permanganate are good. They are good oxidizing agents. Some more reactions we'll see. Continuation. Similarly, sulfide is oxidized to sulfur. Potassium permanganate oxidizes sulfide to hydrogen sulfide to sulfur. So oxygen state is minus 2 for sulfur. It is already given. And here it is 0 because the oxygen state of neutral element is 0. Similarly, Fe plus 2 to Fe plus 3. Ferrous to ferric. It oxidizes oxalate ion, that is C2O4 minus, that is called oxalate ion to carbon dioxide. In oxalate ion, the oxygen state of carbon is +2, and the oxygen state of carbon in carbon dioxide is +4. So +2 to +4 it is increasing, +2 to +3 it is increasing, -2 to 0 it is also increasing. So potassium permanganate oxidizes oxalate ion at 333 kelvins to carbon dioxide. Similarly, potassium permanganate oxidizes ferrous salts to ferric salts. Similarly, potassium permanganate oxidizes sulfides to sulfur. Next continuation. In neutral, faintly alkaline solution. Faintly means light, very slightly alkaline solution. Potassium permanganate, that is manganese permanganate ion changes to manganese dioxide +4 state. So this is called alkaline solution. So equivalent weight is equal to molecular weight by 3. So it oxidizes iodides to iodine, iodate. What is the oxidation state of iodine? Here it is -1 and here it is +5. So -1 changes to +5. So it is increasing oxidation. So oxidation of iodide ions to iodate, iodides to iodates, iodate ion, that is IO3 minus. Similarly, thiosulfate, that is sodium thiosulfate to sulfate. So it is SO4 2 minus. So it also oxidizes thiosulfate to sulfate. Manganese salt to manganese dioxide. Manganese salt to +2 state to +4. And here you can say it is disproportionation also, because +7, +2, +4. Zinc sulfate or zinc oxide catalyzes both the reaction. So what is the catalyst for all the above reactions? Either zinc sulfate you can take or zinc oxide. In permanganate titrations, hydrochloric acid is not used since HCl gets oxidized to Cl2. Very, very important point. So in permanganate titrations, we will not take HCl because HCl acid is getting oxidized to chlorine. That's why, as permanganate is is a good oxidizing agent, it even oxidizes HCl to Cl2. So that's why in permanganate titrations, hydrochloric acid is not used. Next, structure of manganate ion. So manganate ion MnO4 2 minus, it is green color, and permanganate ion is purple color. So manganate ion is green color and permanganate ion is purple color. So both are tetrahedral, and manganate ion is very important. It's paramagnetic because of presence of unpaired electrons, and this is diamagnetic because no unpaired electron is present. No unpaired, because once if we take into consideration one potassium, so O minus K plus, so no unpaired electron, and this is paramagnetic because one unpaired, and this becomes unpaired because anyway KMnO4, so K2MnO4 you cannot say, so K2 also if we take, so it is paramagnetic in nature, and this is diamagnetic. Very, very important point. And number of sigma bonds and pi bonds easily by the structure you can write. So 1 sigma, 2 sigma, 3 sigma, 4 sigma. So 4 sigma bonds and 2 pi bonds. For this also same, 4 sigma, sorry, here 1, 2, 3, 4 sigma, 3 pi bonds. 4 sigma 2 pi bonds and 4 sigma 3 pi bonds. So the structure is very, very important. Manganate ion is paramagnetic in nature, whereas permanganate ion is diamagnetic in nature. This point is very, very important. Please note it down in your classwork. So it is paramagnetic green color and it is purple color, even though it has no unpaired electron, but it is having slight small, that is purple color, and is mainly it is diamagnetic in nature. So it is a good oxidant and is used in laboratory. It is used as bleaching agent for wool, cotton, and silk for the decolorization of oils. So potassium permanganate is used as a good oxidant and used in the lab. It is used as bleaching agent for wool, cotton, and silk, and for the decolorization of oils. I hope it is clear. So with this, I'm ending this session. So in the next session, we'll discuss totally. So till here, we have completed. We have completed the explanation part of D block elements. So in the next session, we are going to discuss some more properties of D block elements along with questions based on entire chapter in the next session. So This session I'm ending with this. Thank you all.